In this problem, we're given a velocity function. That's a velocity as a function of time for a particle. And in part A, we're going to compute the displacement on a given time interval. And then in part B, we're going to look at the acceleration at a particular moment in time. So to review real quick, if I take a time integral of a velocity function, I would start by guessing the antiderivative of the velocity, but that is the position as a function of time. And when I evaluate across the endpoints, I get x of t2 minus x of t1. In other words, the final position minus the initial position. And that is what we mean by the displacement delta x. So my plan here is to integrate this thing on the interval 2 to 3 seconds. And our velocity function was 10 minus 9.8 t. And I have to guess the antiderivative. And in the second term, I add 1 to the exponent on t. That gives me t squared. And then I divide by that 2. And 9.8 over 2 is 4.9. So I have 4.9 t squared. And we plug in the upper and lower limits. And when I run the numbers on this, I get negative 14.5 meters. In part B, I want the acceleration of the particle at this particular moment in time, t equals 1.5 seconds. And here I have to remember that the acceleration as a function of time is the time derivative of the velocity function. But that derivative is just negative 9.8. In other words, the acceleration is always the same exact value of negative 9.8. which you may recognize as being typical for a free fall problem. To wrap things up, we should put units on that, and that's negative 9.8 meters per second squared, and we're done. If you enjoyed this video, or at least found it useful, check out another one by clicking one of the links on the left, or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.